Hi everyone, my name is Hovannes Kulhandjian and I'm a faculty in the Department of Electrical and Computer Engineering at Fresno State. I'm excited about the Finish in 5 program to finish bachelor's and master's at Fresno State. And part of that program is to partner with faculty to conduct research. Accordingly, I'd like to share about my research lab and what we do, and hopefully you can join our research lab. So the research we conduct is on artificial intelligence and wireless communication. The lab is called AI YCOM Lab. And today's talk, briefly, I'll talk about two of the projects that I have been working on intelligent transportation systems. My current research is on applied machine learning, artificial intelligence, wireless communication, underwater acoustic communication, visible light communication, software-defined radios, precision agriculture using drones, intelligent transportation systems. If any of these topics interest you, please come and talk to me. We can discuss some research ideas. So I'll present to you my first project. This is my students working under my supervision for the research project. And so the first project is about detecting pedestrians using artificial intelligence and sensor information. So this system that we have will be placed in autonomous vehicles or in general vehicles and can alert the driver whenever a pedestrian crosses the street, especially at night. So research shows that most of the casualties, pedestrians casualty happen at night. So detecting pedestrians at night is a very strong and ongoing problem. So as you can see in the news in Fresno, a lot of pedestrians, have been killed because of the car accidents. So our goal is to automate the system and it can detect and avoid such type of accidents. Even a young child, 8 years old girl died, was killed because of the car accident. So we are using machine learning, deep learning model to train the artificial intelligence model so that it can automatically detect the pedestrians during the day as well as at night using multiple different sensors. So as you can see, using infrared camera in this far right corner part of the pictures, there are pedestrians, but using a visible light camera, it's very difficult to observe, while the infrared camera can distinctly identify that there are 4 pedestrians. So using that type of information, the machine can learn and then identify and alert the driver. So as I mentioned, you can install this system in the next generation of cars. And we used multiple different hardware, the microdoppler radar for detecting the pedestrians, the infrared camera for night vision, as well as the visible light camera and computer on chip, which is a Raspberry Pi. This whole system was integrated and installed in a car. And as you can see, our system was able to identify, using the machine training, the pedestrians crossing the street. That's the microdoppler radar detecting the signatures from the pedestrians walking away or running or coming close to the car. We developed the hardware and the software peripherals needed for the project, and we trained the infrared camera, microdoppler radar, as well as the visible light camera machine learning models, and then we put it in the car to test it out. So our students gathered the data. We also took some data from online resources. The more, as they say, merrier. So the more data you have, the better results would be. We were able to achieve 99.6% accuracy detecting pedestrians during the day using a visible light camera and some of the images that we used in our data set. And using the infrared camera, all of the images were gathered by my students. And at night, we were able to achieve, again, high accuracy, 97.26%, which is very good. And this is the microdoppler sensor that we used. And the whole setup was installed in the car, and we automated and we were able to detect pedestrians successfully. And we did a demonstration for that as well during the day as well as at night. Now, for the next project, which is a current project, I have a number of 4 students working on that project. All of them are undergraduate students. and each one of them has different expertise. So this is about a bridge and road inspection using drones and artificial intelligence. So the idea is to inspect the bridge and the road, having men and engineers go on the bridge and inspect. It's a very, very, very costly process. So we want to automate. As you can see, on average, it can cost $59,000 to inspect a bridge. So having an automation, a drone going into the bridge or the road area and then inspecting, that will be of tremendous amount of manpower, and then saving a lot of money to the companies. So the current research using some of the tools, which is not practical and it's time consuming. So our idea is to use drones that could autonomously travel around across the bridge and scan the bridge and identify where the malfunctioning parts of the bridge might be, as well as the roads. Like you can see the drone flying over the roads and finding the puddles, and then mapping out where the puddles are, and so the engineers can send the crew to fix those puddles. As you can see, having a regular camera cannot give you insights into the interior structure of the bridge, while the infrared camera can distinctly identify that there are some damages in the metal. So this infrared camera, again, can be very useful in finding faults in the bridge. So we are utilizing not just the regular camera, but as well as infrared camera. As you can see, it can identify well the cracks, and we can use the machine learning model when this is the drone my students are building using the infrared camera, as well as the visible light camera and some computer on chip. We'll be sending out these drones into the streets as well as the bridge to inspect and identify those types of problems in the bridge. So again, we'll be using machine learning, training the model for inspection of the bridge, and using the infrared camera to identify those faults. So if you have any questions, please contact me. This is my email. You can call me also to my office. And special thanks to my sponsors of this project.